AP Chemistry Problem number 12. Consider the carbon dioxide molecule CO2 and the carbonate ion CO3 2-. For part I, draw the complete lowest electron dot structure for each species. For CO2, carbon is the center atom, has double bonds for both the oxygens, which both have 2 electron pairs each. For CO3 2-, carbon is the center atom, and there are 3 oxygens connected to carbon. So 2 of these oxygens are single bonds with 3 electron pairs, where the remaining oxygen is a double bond with only 2 electron pairs and has an overall charge of 2-. For part 2, account for the fact that carbon-oxygen bond length in CO3 2- is greater than the carbon-oxygen bond length in CO2. So in CO2, there are double bonds between the carbon and oxygen molecules, while in CO3 2-, the carbon-oxygen bonds are resonance forms. Therefore, the carbon-oxygen bond's length is greater in the resonance form than that in the double bonds. B. Consider the molecules CF4 and SF4. Part 1, draw the complete Lewis dot structure for each molecule. For CF4, carbon is the center atom, and it has 4 fluorines connected to it with a single bond. So each fluorine atom has 6 valence electrons. For SF4, S is the center atom with 4 fluorine atoms connected to S. Each fluorine has 3 electron pairs. S also has another electron pair because S can break the octet rule and can have more than 8 valence electrons, so it has the 4 shared bonds and the 2 lone pairs of electrons. For part 2, in terms of molecular geometry, account for the CF4 molecule is nonpolar, whereas SF4 molecule is polar. CF4 has a tetrahedral structure, so the bond dipole cancels and is therefore nonpolar. However, in SF4, it has a trigonal bipyramidal structure with a lone pair of electrons, so the bond dipoles do not cancel, and so the molecule is polar.